Here we have the video solutions for fourth period's quiz on algebra practice. So look at number 1. It says simplify, so that basically means we just compute until we can't compute anymore. So I do have a subtraction here, so I'm going to do a same chain switch. So I have negative 8 plus 6. So we know we take the sign of the bigger number, which is negative, and subtract. So that's negative 2 plus a positive 2, which of course they're opposite, so we get 0. Number 2, 13 minus 14 plus negative 1. So we're going to do same chain switch here. Okay, I have a positive plus a negative, so I'm going to take the sign of the bigger number, which is negative, and subtract 1, or subtract, so I get negative 1. Then I have negative 1 plus negative 1. Obviously that's negative 2. Okay, number 3, we have a couple subtractions, so I'm going to do same chain switch for both of them. So you notice there, that's plus a positive. So 10 plus 9 is 19. So then I have 19 plus negative 15, so I take the sign of the bigger number, which is positive, and subtract. So I'm going to get positive 4. And then I'm going to add 4 plus 4 to get 8. Okay, so number 4 now we have decimals. So I'm still going to do my same chain switch. And I'm still going to think of my integer rule. So here I have a positive plus a positive, so I'm just going to add them. So I have 3.5 plus 9.1. So I get 12.6. And then I'm going to add that negative 8.6. Again, I have a positive negative, so I take the sign of the bigger number, which is positive, and this time I'm going to subtract. So 12.6 minus 8.6 gives me 4, or 4.0. Okay, number 5, I have subtraction, so I'll do the same chain switch there. Okay, first two I have negative plus a negative, so we know it's a negative. This one I'll just do in my head, so I have 0.6, 0.7, that's, or 0.1, that's 0.7. 4 and 2 is 6. So I have negative 6.7 plus negative 5. So negative plus negative just gives me more negatives. The 6 and the 5 will give me 11. And then I have that 0.7 left over. Number 6, positive subtraction, so let's do the same chain switch. So here I have a positive and a negative, so I'm going to take the sign of the bigger number, which is negative, and here I have to subtract. So I have 7.2 minus 5.07, so we have to line up our decimals. I fill in that place. So here in this instance, I have 10 minus 7 is 3, 1 minus nothing is 1, 7 minus 5 is 2. So I have negative 2.13 plus 0.94. So I again have a negative and a positive, so I take the sign of the bigger number, which is that negative. So I'm going to have a negative, and I subtract again. So 2.13 minus 0.94. So that's going to be a 9, borrow. It's going to be a 1, and I have a 1 left over here, and I already knew it was negative. Okay, number 7. Okay, I'm adding a negative and a positive. It doesn't matter whether it's a decimal, a fraction, an integer. I still use the same rule, so I have to determine which is larger. So 2 times 5 is 10. Over here, 1 times 3 is 3. My 10 is larger, so this 2/3 is larger. So my answer will have to be negative. And then that also tells me I'm going to do 2/3 minus 1/5. So our common denominator will be, it looks like 3 times 5 is 15. So 5 times 3, so 1 times 3. 3 times 5, so 2 times 5. And 10 minus the 3 is 7/15. And I already knew it was negative. And number 8, well, just like all my other problems, I have subtraction. In this case, it's even more important because in subtraction, I have to borrow. Notice there's nothing here to borrow if I leave it the way it is. But when I do my same chain switch, and I figure out which is larger, 1 times 8, 4 times 5, this fraction is larger. So because it's larger, I know my answer is going to be negative, but it also tells me that I have to turn this problem around and do 5/8 minus 1/4. So it looks like our common denominator is going to be 8. 4 times 2, so 1 times 2. 8 times 1, so just 5 times 1. And now 5 minus 2 is 3/8. We already knew it had to be negative. Okay, expression. So I'm going to substitute negative 5 in for x minus, substitute 9 in for y. I'm using parentheses so I make sure I substitute correctly. Here I'll do my same chain switch. So I have a negative 5 and a negative 9, which means they're negative, and I add them up. Okay, number 10, I have a negative, but then I have my x, and then my y, so x is negative 5. So I actually have a negative negative, which makes this a positive 5. That would have been 9. So 5 plus 9 is 14. Okay. Number 11, I have my y minus 4 minus my x. So y is 9, and x is negative 5. So I don't want to get this minus right here mixed up with the negative. So by using parentheses, that helps me. So let's do our same change switch. Same change switch. So 9 plus negative 4 is going to be positive 5. And then 5 plus 5 makes it 10. Okay, number 12. Well, this is all multiplication. So I know that whenever I have two negatives in multiplying and dividing, it makes a positive. So negative times a positive would be negative, and then that negative times that negative would make it positive. So I find it just easier to just count the number of negatives to begin with. I know my answer will be a positive number. And then just multiply. 2 times 4 is 8. 8 times 10 is 80. Okay, here I have a positive times a negative, so I know my answer is going to be negative. When we multiply fractions, we simply multiply top times top, bottom times bottom, and simplify. And that already is simplified. So negative 7/3. Okay, I know when I divide fractions that I have to do same change switch. So I'm going to keep the first fraction the same, change division to multiplication, and flip this to its reciprocal or its multiplicative inverse. Now I have a positive times a negative, so my answer is negative, and I'm going to simplify. Do not simplify here first, like the 2 and the 6. That would create a problem. Simplify after you do same change switch. So I know that 3 goes into 3 once, and 3 goes in there twice. So now 5 times 1 on the top, and 2 times 2 on the bottom. So my answer is negative 5 halves. Okay, number 15. Well, we have to do distributive property first. So outside times everything in the inside. So I have 6x minus 12 plus 2x. Okay, you can go ahead and do your same change switch if you want. Then I'm going to combine like terms. So I have 6x and 2x is 8x. And then I have my plus negative 12. So another way to write that, if you didn't do your same change switch up here, would have been 8x minus 12. Okay, number 16. Go ahead and do a same change switch if you want. So I have to multiply here with numbers in front of parentheses. So 2 times negative 4x is negative 8x. And I have my plus 6 plus negative 4x. Okay, the reason I want to do my same change switch is if I didn't, it would look like this. And some kids then, when they combine like terms, think that's a negative 8x and that's a positive 4x. They forget that this acts like a negative. So I would just as soon you take care of that same change switch to begin with, and you won't make that error. So now I have a negative 8x and a negative 4x is negative 12x plus 6, and that's all I can do. Okay, we know from class that this minus in front means I have to distribute it throughout the parentheses. So if we put a 1 there and now do our same change switch, that's actually a negative 1. So now I can do my distributive property. Negative 1 times x is negative 1x plus negative 1 times 3 is negative 3. And then I have this negative 3x there. Okay, I have a negative 1x and a negative 3x. This is a negative 4x. Positive 11, negative 3 gives me positive 8. So hopefully this helps you and allows you to figure out your mistakes and you can come in and retake it.